Hi, good evening everyone. I'm Justin from Group 7. So now I would like to present the assignment 2 for Engineering Mathematics 3 for ECC3003. These are our group members, my group members, Group 7. Basically, this assignment is intended to let students to appreciate the application of Fourier transform in our real life. Let's start off with the introduction first. What is Fourier transform? At high level, Fourier transform is a mathematical function which converts non-periodic continuous signal in time domain to continuous signal in frequency domain. This is a very powerful transformation which gives us the ability to understand the frequency or to know more about the frequency inside a specific signal. For example, you can take an audio signal and detect sounds or tones inside the signal using the application of Fourier transform. Now I would like to present you the general formula for finding Fourier transform. It's given that fj omega equal to the integration of ft exponent to the power of negative j omega t dt from negative infinity to infinity. Basically, this assignment is mainly related to the usage of filters or filtering in our real life. What is a filter? In signal processing, a filter is a device or process which removes some parts or some components or features from a signal. Filtering is a class of signal processing, the defining features of filters being the complete or partial suppression of some aspect of the signal. Generally there are several applications of Fourier transform. Now I got a question for you all. How can a signal be made better? Suppose that you are listening to a recording and there is a low pitch hum in the background. With the usage or the application of a low frequency filter, we can eliminate the hum. Or in the other situation, suppose you have a digital photograph and it's very noisy. There are random specks of light everywhere. Therefore, thus we can use signal processing and Fourier transform to filter out this undesirable noise from through the usage of Fourier transform. This is the list of filters that we use. As reference to the audio outputs which undergoes different types of filtering, and the different types of filtering are comprised of all these four. The first one, as we can saw from the output, these four types: high pass, low pass, band stop, and band pass filter. So now I would like to briefly explain about the usage or the definition of these four kinds of filters. The first one, low pass filter. What is a low pass filter? Low pass filter is basically a filter which allow low frequency to pass through, whereas the high frequency are attenuated. The second one, high pass filter, is that whereas the high frequency are passed and the low frequency are attenuated. And the third one, the band pass filter. For this one, is only the frequency within the frequency band are passed, and it will reject or attenuates the frequency outside the specific band. The last one will be the band stop filter, or we also known as band rejection filter. For this filter, which allow it's only frequency within the frequency band are attenuated. Now I would like to generally brief about the usage of signal smoothing using Fourier transform. These are the findings which I found through various sources like website or books. Firstly, Okay, initially this is signal in time domain. Okay, this one. Okay, after you undergo Fourier transform, you will become this spectrum or this signal in frequency domain, and then which undergo filtering or filter, or we also known as smoothing, and the signal will become this. Some parts of the frequency are being removed or being attenuated, and this signal which undergoes inverse transform, okay, it will become the filter signal as as this shown. Okay, now I would like to present you about the usage of MATLABs in order for us to generate different type of filter outputs. Okay, this decoding that is used to generate the different types of filter outputs. Yeah, after we have figured out several or different types of graphs with waveforms are generated as shown. Okay, firstly, for this one is the graph for low pass. This is the magnitude and this is the phase. Okay, whereas this one is the low pass filter. Only those which only allows those frequency below the cutoff frequency to pass through. And yeah, this is the low pass filter also. This is the input spectrum. So after undergoing filtering, and the waveform become like this. The low frequencies are being attenuated. And then this is the high pass, which allows the high frequency to pass through only. And okay, yeah, this is the impulse response of high pass. This is the time plots of input and output high pass, which only allows the high frequency to pass through also. This is the input and this is the output, which after undergoing the filtering process. Okay, this is the high pass also, which allow the high pass the high frequency to pass through. And for this one is the graph of frequency response band pass. This is the band pass also. Yeah, this band pass also. Okay, this is signal, and then this is the filtered signal band pass waveform. Okay, band pass is which only allows those frequency within the specific band to pass through only, whereas the others outside the band, the frequency outside the band are being attenuated. And this is the input and output spectra band pass, which also allow the frequency within the specific band to pass through. And those which are not within the specific band with this are being attenuated after the filtering process. This is the frequency response band stop. This is the impulse response of band stop, and the graph shows you the amplitude of it. And this band stop is the input signal and the output signal, which undergo after undergoing filtering process. Band stop we attenuated the frequency within the specific band, and this band stop. Yeah, and as you can see from the graph, is the input, and then this is the output, and this one is within the frequency band. So after the filtering process, the frequency are being attenuated. Okay, basically, Fourier transform can be in sum, Fourier transform is a very important process for us to in signal processing, or for us to filtering out some some unwanted or annoying noise, or to remove some unwanted frequency that we don't want in our real life. So that's all from me. Thank you.